I'm Eric Klotchik. I'm the director of the Hurry Institute for Computing. It's my pleasure to welcome you to the third of our Did You Know You Could series. This is meant to be a unique sort of series. In non-COVID days, we'd all be sitting around with brown bag lunches around the table. It was meant to have that sort of feel and flavor to it. So it's not meant to be something where you just sit for an hour and listen to someone talk. It's meant to present topics to you you might not have even known you wanted to know about, but when you saw the flyer, you said, oh, actually, I'm going to go to that. And it's meant in particular to help you get over low barriers, right? So open to the general BU population, focusing on topics that easy to get up to speed and get started in. And hopefully you get large value added in terms of taking your computing and data science in new directions. The series is led by our Institute Graduate Student Fellows. So the Hurry Institute Computing Graduate Student Fellow Program started in 2017. It's meant to recognize graduate students who've really made a particular impact or set a promise in the area of computing and data science. We have 18 of these graduate student fellows so far, and I'm very grateful to them for having taken on their shoulders the running of this program. Today's host is Beverly Setzer. So Beverly is a 2020 graduate student fellow. She's with the graduate program for neuroscience. She got her BS in mathematics with a minor in biological sciences from NC State. And as part of NC State's Biomath Research Training Group, she helped develop a method for detecting hidden nodes in neuronal networks using nonlinear Kalman filtering. She's currently with Dr. Laura Lewis's lab here at BU studying human brain dynamics during arousal from sleep, using advanced imaging on the one hand and computational models on the other hand. So welcome everyone again, and I'm going to turn it over to Beverly to introduce the speaker.
Thank you so much for the introduction, Eric, and thank you all for attending. Before I introduce our speaker, I'd like to take this opportunity to get to know our audience a little bit better. I'm going to ask you to answer 3 questions. And for the first question, we ask you to please type your answer in the Zoom chat. So we'd like to know what your field of study is, and if you please respond in the group chat. Awesome. So it looks like we have a nice mix today. So we have people from mechanical engineering, computer science, political science, biomedical engineering, neuroscience. So that's awesome. Thank you all for coming. It just shows how versatile GitHub is. And then our next question, we're going to use the poll feature for. So we would like to know what your familiarity is with GitHub. None, a little, familiar, or very familiar. Is the results from the poll supposed to type up where? Oh, there it is. Okay, right as I was asking. So it looks like most of us are a little familiar. So I'm also in that boat, but we do have some people who are more familiar and a couple who are very familiar. Our last question is, what would you like to learn from today's series? And if you would please just type your response in that chat again. So people would like to learn general workflow advice, how to make their GitHub portfolio better, good source control practices, how to skillfully back up, upload, and download the code. So thank you all for answering those questions for us. Now I'd like to introduce our speaker. Katya Bilikova is the Manager of Scientific Programming and Applications in Information Services and Technology. She has a master's degree in mathematics from Moscow State University. Her current research investigates different approaches to integrate information contained in the network structure of data and assess their performance using a real-world health laboratory data set. And with that, I will let Katya take it away.
Good afternoon, everyone. It's nice to see. I think I know at least some of you, and it's very useful for me actually to see the answers that you posted about what you would like to learn. I wish I actually knew those answers a little bit earlier, but at the same time, I think we will have some time to answer those questions that you posted that will not be included in my general presentation. So let me share my screen with you. Okay. Let me see if I can see the chat just in case. And with this, let me just say that in today's presentation, I'm trying to, I tried at least to come up with some general advices that would be helpful for those of you who just starting using Git, who have used Git for a little bit, and for those who are really familiar with this product. However, Git, just like any branch of science or any language, is a very, very broad subject. So I would just encourage you to keep learning. And at the end of my slide, you will see some links that you can use to discover more about Git and GitHub. So first of all, I want to say that there are, at least for those of you who are just starting to use Git, that there's Git and GitHub. Those two things are present two different concepts. One, Git is a distributed version control system. It allows you to back up your files and keep track of your work, when GitHub is actually a web-based hosting service where you share your work with others or use it as an additional backup repository. So in its very simple format, you would use Git to back up your work. You say start working the project on in this example April 9, 2019. And you start with some files, like you can see here, my data and some maybe code. And then you keep working, and at every once in a while, you keep snapshots of your code. Here I added another file and probably modified the previous file, and you keep doing that until you reach the time when your project is complete and you no longer need to work on that. That is if you use Git just to work by yourself. You can then, at any point of the time, you can publish your work, or you can keep this version control system just local to your computer. GitHub, however, allows not only to keep versioning of your code local to your computer, it also allows collaboration between multiple people on the same project. There are many features on GitHub in addition to just supporting this workflow, and I will share with you just a few of those that you might find useful. So first of all, not that many people know that with every repository that you use in you publish in GitHub, there is also Wiki Page. And here's an example of Wiki Page developed by D3 project, the project that develops a language for graphics for the website. So here is this repository, and you can see that it provides, together with the code for this D3 library, it also provides a very easy to use tutorial. And that just to explain why that is important, I noticed one question that was one answer in a Slack, in a chat that you posted, how I can improve my GitHub repository. This is a very easy way to actually not only to document your code, but share with, if you, for example, look for a job, or when you apply for a job, people will see at your GitHub repository and can estimate your documentation skills, right? In addition to your coding skills. Let me find the other part of the GitHub repository is projects. So you can here you can work together if the code that you're working together is a part of a larger group effort. Here you can use this tool to collaborate on what tasks need to be done and keep track of issues that arise with the code, pull requests, some actions that need to be done on your code. And as you can see, here is another example from the Bootstrap project where they collaborate with each other. And if you used Trello in the past, this is very much like that. So those tools are easy to start and easy to work, even if you are a very beginner with Git or GitHub. Now, to show you a few other useful tools in Git and GitHub, I also wanted to say that within academia, when you work at university, you normally work in centralized distributed workflow where you have a group of people who contribute to the same shared repository. And this is the most simple way to work on a project. However, if you at some point will work in a larger project where there are potentially dozens of people who contribute or even more, there's another distributed workflow where there's a central repository and there's a manager or managers to that repository. And individual developers, they would maintain their own forks or copies of this central repository, work on that, and then ask to pull their work to that central repository where they finish developing any features. So it's important to know both styles, especially if you are planning to go and work in industry. However, it does mean that you have to start and explore both of them. I would start small. I would start with something basic. And then when you are very comfortable with this, you would go to this more complicated workflow. At the base of any workflow, whether you actually work by yourself, together with a few people, or together with a very large number of people on the same project, there's a concept of merge, branching and merging. So this concept is related to that you have one main branch that contain the final version of your code, and there's a branch which could be belong to you, just to you, and you work personally on that branch, or you can think about that branching as different people working on the same project. once either your new feature is developed or once you finished and you would like to merge it to the main branch, some sort of merge occurs. There are a number of ways to do that, but the power of Git allows very easy way to merge work of multiple people. So first of all, just very quickly, I wanted to say that with the discussion that started this summer, many people pointed out to this very outdated way of labeling the main branch. For a long time, this main branch was called master. And right now the effort is going to change this habit and make Git, just like the rest of the world, more inclusive. So I would encourage you, when you start a new repository, to rename your main branch, which very often comes by default as master, to be main. And here how you do that. I would be very careful with doing that with your old branches, especially if they are shared with multiple people. We shouldn't really be changing our history. We should own the history, but at the same time, going forward, I would encourage you to get into the habit making your main branch have a different name. And it's easy to do. If you want to see more instructions, you can see at the bottom of the slides, there's a link for that. Then I also wanted to point out, for those of you who at the beginning of working with Git and GitHub, that when we commit our code, it's very easy to write very short messages about our updates. And as you can see, here is a very usual style of commit. It's code update. But the whole power of Git in general is to be able to know what actually was changed, why that change was made, what was improved. And to do that, I would encourage you to actually use the full format to commit. However, the default commit message that you would develop might not be easier to use. So I often recommend to use a template. And to create a template that works for your group, you can create a file called .git message, which you would put into your home directory or some other location. And then you would add to your global or local configuration this template. What is useful with this template is that you can actually format in such a way that it would be helpful to make meaningful commit messages. For example, your first line should always be less than 50 characters maximum. And as you can see here, I created a comment line that is exactly 50 characters. So when I will be using this template, I will know where to stop my short commit message. And then again, depending on the workflow of your group, you might define some other parts where you can specify what messages should be included with every commit. And again, since every line should be less than 72 characters, you can see that my comment is designed in such a way that it's 72 characters long. So whoever uses that template, he would know where to put his break into the line. And so when we use this style of commit, instead of having just a meaningless message, we can have a message that would serve its purpose, and then some other accompanying messages that would, for example, that could explain how to test this commit, or how to where more information can be found. Sometimes this is another, I would say, easy trick, but important trick, is that sometimes there's a necessity to rewrite the history. First of all, you should always remember that once you submitted your changes to GitHub or another remote server, you should never rewrite the history, okay? Because it now belongs to the world. It belongs to your colleagues. You don't want to break their repository. So you should only use, you should change your previous commits only when they are still local to your repository. And one easy, one time that it's very useful sometimes to use to rewrite the history is when your previous commit message contains some typo or error and you want to amend it. You can use git commit -- amend command and fix commit message, or maybe add some another fix to your commit itself, and then your commit will be fixed. This is, I would say, more advanced command. If you plan to work in industry, it's actually really important that every commit that you have makes sense, that every commit works. So you don't, your work will not be accepted, your pull request will never be accepted if at least some part of your code doesn't work. Right, so you might introduce some bug 3 commits ago, and then you didn't notice. You keep working on your code, and then at the last commit, you might figure out, okay, the 3 commits ago, there was some part of my code where I had division by 0, or where some bug introduced that I didn't notice. And there's a very handy git rebase interactive command that allows you to either change that commit, and it will then modify all commits starting from that commit going forward. So for there are multiple options. You can squash commits, you can fix commits, or one feature that I probably wanted to show you very quickly is some command that you can use to run a test. So here is my repository. You can see I have here some commits. The last 4 commits have not been published yet, and I can type git rebase -i, and it will show me those 4 last commits. And maybe I suspect that there was some bug introduced in my R code somewhere after one of those commits. And what I can do, I can insert a line here, and I can say, can you execute X with, you can see here X, can you execute my R script here? And maybe I want to execute it also after this commit. Okay, once I do that, and again, you can see there are many other things I can do with this functionality. But here, I just want to check whether my script runs correctly. I save and exit, and it starts to execute, and it shows, okay, you know, I ran this I ran that script successfully here. The result was 0.5. I ran the script here again successfully, and here is the result. And since everything ran successfully, it says I rebased. If there were any modification, I rebased everything, and everything is now up to date. However, if let's say the script here executed with errors, it would stop here and would allow me to modify the script for that commit, and then it would merge those changes to all commits that went after that commit. So that's a very nice and handy way to fix some previous commits that where you might have introduced a mistake. Once you checked everything, once everything is working, you can push your changes into main repository, or if you work in a more complicated system where there's some manager of main repository, you can send a pull request. Okay, and with this, I also want to share with you my favorite book about Git itself is the one that comes from the Git repository itself. It Pro-Git by Scott Jason. And you can find also some information about how you can modify your wiki page, or how you can make a project management on a GitHub on these web pages. Again, if you have some other specific questions, I will be happy to share with you where you can find resources for those pages. Thank you very much. Let me see if there are any questions in the chat. Beverly, let me know if how I'm doing with the time.
Yeah, that was great. So we have about 30 minutes for questions to have more things explained. So if our audience has questions, you can ask it in the chat, or you can feel free to unmute yourself and ask that way.
Yes, and I can also look through the answers that came from your main question, what do you hope to gain from the today's presentation? General workflow advice, it's very hard to give a very general workflow advice, because it really depends on whether it's your personal repository or it's distributed repository and how big it is. Okay, so in general, I would say if you are a beginner with a GitHub, you should concentrate on developing the right code and make frequent updates of frequent snapshots to your repository. That's the main factor. You should not necessarily concentrate, okay, my snapshot should be, every commit should be perfect. I would say that's not the goal. But going forward, once you are very comfortable with a Git command, I would start learning, adding more and more commands to your to your knowledge, and then you can start thinking about making every commit perfect. Saying that, I would say the command that I just shared with you, rebase -i, would allow you to take some semi-final commits. Let's say you made some commits that does not really add a full feature, but only some part of it. You can then use the command I shared with you to squash those commits into one meaningful commit. Okay, that's if it's your individual workflow, if you are working on your local branch and you developing some feature for the full group. With those who, let's say, would like to work on some open source project, like either with Red Hat or with another industry, I would highly recommend to go through more advanced features that are available in Git and learn how to to use bisect command, how to use that continuous integration that is available in GitHub, and much more advanced features, because you want your commit to be, at that point, you do want your commit to be perfect. I want to make my GitHub portfolio better. I actually, in the past few years, I had to hire a number of people in my group, okay? And one thing I always ask is, do you use Git? Do you know Git? And there were types of answers, but some of them say, well, I'm not familiar, and that's a reasonable answer. But with those people who say I know Git, there were two different styles of their answer. Okay, yeah, I have a GitHub account, and then I click on that GitHub account and it's empty. The first and the last commit was done yesterday. Okay, that's no good. Okay. Saying that, not everyone, especially when you work at the university, not everyone can contribute to some big, famous open source project. And I would say almost no one requires you. When I look at people's GitHub, what I'm looking for is how their code was written, even if it's a homework, if it's a homework for the class assignment, if it's all big, if the code is big, what I call spaghetti code, without a single comment, when it's no one, even the author, can say what's going on there, then it tells about how this person writes the code. And even if it's a simple code, but it's nicely organized, and even better, there's if it's some R or Python package that was developed by that person, there's a wiki page or some nice documentation. It tells that the person actually knows what he is doing. And there are also, by the way, there are some GitHub how they call them, not individual, personal pages that are easy to create, and depending on your, I would say, HTML skills, you can make them really stand out. But I would say that the code and the way you document the code is most important in your GitHub repository. Good source control. Let me first of all see the new messages. I have several large files related to my code, which needs to be shared with collaborators via GitHub. Large matrices or data files. Can you talk a bit about the pros and cons of using Git large file storage, LFS? First of all, GitHub has limits in size. So everyone, the GitHub does not allow to have unlimited storage unless you have some paid service. So yes, with large file system in Git, that's what you would use for. And I would say what it basically does, it makes the action only when you really need that file. So it still needs to store the files. It still needs to, if you will use the file, it will upload or download, and you will be facing, if you have a very slow internet, that wouldn't really solve much problem. So what I would recommend is that before you put anything into GitHub, I mean, add to your GitHub repository, you should think very carefully about two things. First of all, you need to make sure that you don't change those data often. If you do, you don't want to add it to your Git repository. If it's a one-time change, if it's in the like input file, that's one thing. If you plan to, let's say, recreate those images every time you use your code, then you shouldn't use neither Git nor GitLab to GitLFS to store, to add them to the repository. And the other thing I would say, you should think very carefully about the format of the data. If it's a text data, you probably want to, there are a number of ways to optimize it, to optimize the storage. And again, that would really depend on what kind of science it is. There's various ways to make those files smaller. And another way is to post that the files, the data files, somewhere else, not necessarily through Git, but through some other service where you can, through your Git hub repository, point out and say, okay, you can download the data for that repository. There was a question, tricks to improve efficiency through the workflow. Here is a little bit unclear question, efficiency of the code.
I mean, that was my question. I wanted to clarify it much better. So like usually in my projects, what happens is that I will be testing the code, whether it's bug free and all on my own computer, but when I have to run it, I run it on the servers. So a lot of time it happens that the environment will be different. And on the servers, you'll have to make certain changes which are not required for your local desktop. And I mean, the problem is that if I make any changes on the servers, then they again get reflected as not committed, modifications, right, in the Git repository. So a lot of times, like if I'm making those changes, I have to go through them and keep in mind that I don't have to add those to my commits. And again, it becomes a huge problem when I'm trying to transfer code, like not transfer, but like use the same exact, the distribution or the work structure, work tree for both my local as well as the server, repositories, the local repository. So if you could just give us some recommendations, like how could we optimize those kind of things? Like if I'm using something on my local desktop, like is there a better way to use it on the remote servers as well while not committing those unnecessary changes?
One way to deal with this, that you would have branches on. So you have your Git repository in a server, right? And you have a Git repository on your desktop machine, right? So one way to deal with this would be you would try to to implement that feature on a server, test it, right? Then you would merge it into your main branch. That, and only after that you would share it with others. And with another thing that I would look into, and it would be very hard to discuss in a short period of time, there's such a thing as work tree. So if you look at, if you Google Git work tree, that would allow you to have an independent copy of your repository where you can, that would share the history with the main repository, but it would allow you to very quickly switch between them and continue to work on your testing in one directory, but at the same time without changing the main repository. So just try to search for Git work tree. Okay.
Okay. Yeah. Thank you so much.
Will we see a better VCS than Git? Here I would answer with the questions, what's wrong with Git and VCS version control system?
There's nothing pretty much wrong with Git, but like I'm a CS student, so I'm always trying to develop new stuff. And I've actually attended this because I wanted to see if you have any things that you find wrong with Git. And if I was trying to develop something like a new version control system, because Git is written in C, right? So, and if you try to make it faster, maybe we could do it on some other language. Maybe.
You find Git slow. I think that Git is probably the fastest version control system that was created. It was actually designed with the purpose that it should take just no time to do anything. So
Yeah,
if you find it slow,
but the problem with Git is that it's not distributed. So if we do something like Golang, we could probably do this, like make it make the tracking parallelized as well. So I was just asking your opinion. I'm not saying it's slow.
yeah. Yes, I would say it's almost, I would say if you find something that doesn't work, it probably means that you are using it in such a way that is not optimal, because the Linux repository is updated by a few dozens of thousands of researchers, and it works pretty well for already a few dozens of, well, for how many years? Well, yeah, for more than 20 or 30 years, it works pretty well. Let's put it this way.
All right.
And it's again, I would say it's almost for those people who work in other version control system. Once you get used to some system, it's very easy to fall into that pitfall. Okay, the thing that I'm using is much better than anything else just because it's much easier. That's there's an endless argument which editor is better, Vim or Emacs on Linux, right? So if you get into the camp of Emacs people, they will tell you that that's the only way to live. And if you go to the people who use Vim or VI editor, they will say that's the only way that, Emacs has, so it's blown up system, it's too large and so on. And there's truth on both sides. But I would say that to defend Git, so far, almost everyone agrees that Git is actually most perfect system design. I would argue that the remote servers, so for example, there's a number of people who don't use GitHub, and there are reasons for that. Very often in past few years, many, for different reasons, people would use GitLab versus GitHub, but it's again, there's specific reasons for that. If you're looking to show off your code, if you want to use it just a remote server, there's nothing wrong with GitHub, but there are certain features that don't exist, and at the same time, first of all, GitLab is a free source, so you can install it on your own server, which you can't do with GitHub. And so
I think there's more firewalls that you can add to GitLab too.
I
think you can add firewalls to GitLab too.
Yeah, as I said, there are many. So between GitHub, GitLab, and other systems, you can find argument why one better than another. But with Git, almost any, depending on your own workflow, you can find the commands that would be most optimal. Yeah. That's why I started. If you're just starting with Git, don't go to and think about every Git. You first need to get into that habit of submitting commits and writing meaningful commits and so on. And then you can build your skills one at a time.
Yeah, that makes sense. Thank you so much.
So I have a question, just as someone who's starting out using GitHub. I have a bad habit of just saving locally and not pushing to GitHub. And so I'm wondering.
That's not a bad habit. The bad habit would be if you didn't commit, okay? Pushing it into remote repository, I would say it's bad habit if you collaborate with many people and they expect you to, and you forget about that. That's a different issue. You need to sort of work together with people. But if you work locally, there's nothing bad about not to push commits, because as I said, sometimes, especially when you start working further with developing your GitHub skills, sometimes some of your commits might be almost meaningless. Let's say you add half of the line you need to run to
Right.
class, and you submit your commit locally, and there's no reason to push it yet. You can then come, finish, and then squash those commits to have a meaningful commit. So I wouldn't call it a bad habit.
Okay, that's good to know. Yeah, I feel like I'm trying to just build my GitHub in case I do want to end up going to industry. So trying to find like so I also do work by myself. I don't have to share code with people. So I'm wondering like if you recommend trying to like set a schedule for yourself or something like that to push, or really just waiting until it's something meaningful and having like a larger push.
So there are two reasons why you want to push your changes. One is when you want to share your repositories. Personally, I actually in my role, I have in my role as a manager, I have so many repositories that I don't want anyone to see. Okay, so they are very private repository, but I still maintain them. So in theory, I don't have to push them into GitHub. However, you will need to remember that our computers die from time to time, right? And that you never know when it happens. So the GitHub or GitLab or any other remote server serves as a backup. So in this case, if it happens that something happens with your computer, you are sure that even if you lost one or two commits, it's not the latest commits. I mean, it's not the end of the world. But having this habit to commit the changes, it's actually a very good habit, because it will then it will develop this workflow, and then it will be much easier to add those more complex commands into your Git vocabulary, I would call it this way.
Okay, great, thank you. I think we have time for one more question. So if anyone else has a question, now's the time.
Okay, no, that was. Yeah, I think I answered everyone in the chat.
Yeah, I think the chat questions have been answered. So I guess I'll just ask one more broad question to finish off the seminar today. So you've given us a lot of good advice and tools that we could use, like the rebase, which is really helpful. I didn't know about that before, but I'm wondering if there's anything that you wish you had known when you started using GitHub that you would like to share with us now, or if there's like any advice you have.
Let me see. And again, I would separate Git and GitHub. With GitHub, I actually was, when I started to use GitHub, I was not aware of all this project and Wiki Pages. And I found that Wiki Pages is actually a very great way to very easily build some documentation that you can share with others. I actually try to enforce it within my team to use it more. That's about that's about GitHub. With Git itself, I would say that you should try different work. I would recommend, if possible, to once you more or less comfortable to work with yourself, to think about any project, and it doesn't have to be a programming project. It could be a cooking project with some friend. You can make it private, you can make it public, but this way you can learn how to work together and how to merge the conflict. That is the easiest way to learn about workflow. And when you work with others, it's sort of like, from what I've hear people say that it's much easier to lose weight when when you have a company of other people who do that, right? So the same thing, to get into the habit of doing regular updates and correctly manage your workflow, it's much easier to do with someone who you are comfortable, not start doing that when you already looking for a job. And
that sounds like a fun way to get used to working with people on Git. Okay, so I think we're going to wrap up now. Thank you so much, Katya, for your presentation. It was really helpful, and I'm excited to use some of these tools that you shared today. We would also like to thank the Hariri Institute for supporting the logistics of the event and making this happen. We hope to see you at the next Did You Know You Could series, which won't happen until January 22nd and will be on the topic Gorilla. And lastly, we have a panel on atypical journeys in computing and data science on December 3rd. And if you'd like to learn more about Git and GitHub, you can visit the GitHub website. They have several guides to get you started. And we can also share Katya's resources that she gave us. Thank you for coming, everyone.
Thank you. And at this time, you can unmute to clap. Let's give it a try. Unmute.
Thank you.
Thank you.
Thank you very much.